Hello everyone. Today we're going to talk about probability and odds. And probability is simply defined as the likelihood of an event occurring. That's what it means. How likely is it that this event will occur? So let's do an example. The formula says that how to calculate probability is the number of favorable outcomes divided by the total number of outcomes. So we're going to roll a die. And as you know, a die has 6 faces. That means one roll will either come up a 1 or a 2 or 3 or 4 or 5 or 6. So this is the total amount of outcomes possible. I can possibly have a roll of 1, 2, 3, 4, a 5, or a 6. These are the total number of outcomes. So let's say I want to look for the probability of rolling a 3, for example. The probability or the likelihood of this occurring is calculated as the number of favorable outcomes. So favorable outcomes means um, which of these outcomes is rolling a 3? Well, this outcome right here is the event rolling a 3. How many of those outcomes are there in a total of 6 possible outcomes? Well, there is a possibility of rolling a 3 only once. Okay, so that means the number of favorable outcomes is 1. Divided by the total number of outcomes, well, there are a total of 1, 2, 3, 4, 5, 6 outcomes. So that would be 1 over 6. And how much is that? When we do probability, we usually write the probability as a decimal. So that gives you 0.17, rounded off to the nearest hundredth. Okay, let's do another example. What is the probability of rolling a number greater than 3? So now the event we're looking at is rolling a number greater than 3. Let's look at our possible outcomes. Which one satisfies being greater than 3? So 3 is not greater than 3, so 3 is not a favorable outcome. 4 is greater than 3, so 4 is a favorable outcome. If I roll a 5, 5 is also greater than 3, so this would also be a favorable outcome. If I roll a 6, 6 is also greater than 3, so 6 is a favorable outcome. How many favorable outcomes do we have? 1, 2, 3 favorable outcomes over the total number of outcomes, which is 6. So 3 over 6 we can simplify to 1 over 2, which is also equal to 0.5. And that is the likelihood of rolling a number greater than 3 is 0.5. Okay? Now I want you to try these two that I'm going to write here so that you can practice. I want you to find the probability of rolling a number that's less than or equal to 4. And I also want you to find the probability of rolling a 3 or a 4. Okay? And then I want you to hit pause, work these on your own, and then come back to see the answer. Okay, here are your answers. We have that the probability of rolling a number less than or equal to 4 is 0.67. How did we find this number? Let's go over it. Less than or equal to 4. Let's go over here to our list of possible outcomes. Less than or equal to 4. 4 is equal to 4, so 4 would be included as a favorable outcome because we want numbers that are less than or equal to 4. So 4 is a favorable outcome. 3 is also a favorable outcome because 3 is less than 4. 2 is a favorable outcome because 2 is less than 4. And 1 is a favorable outcome because 1 is less than 4. So how many favorable outcomes do we have? We have 1, 2, 3, 4 favorable outcomes. And that's what I wrote right here, 4. And we divide it over the total amount of outcomes. We can simplify 4 over 6 as 2 over 3. And you can divide with your calculator and you'll get 0.67. For finding the probability of rolling a 3 or a 4, well, we go to our total amount of outcomes here, to our list, and we look for 3 or 4. So what is the likelihood of rolling a 3 or a 4? Well, how many favorable outcomes are there? Well, only two. Either 3 or 4 are favorable outcomes. So that's why I wrote a 2 here divided by the total number of outcomes, which is 6. You can reduce that to 1 over 3, which is 0.33. Now, I want to draw your attention to this sort of a straight line that I drew here. And notice that p equal to 0, p equal to 0.25, 0.5, 0.75, and 1. These p's mean probability. And what I want to show you is for you to have an idea what these numbers that we're finding mean, okay? So having a probability of 0.17, of 0.5, of 0.67, of 0.33, what does that mean? And this is a scale. So 0.17 would fall right in between 0 and 25. A probability of 0 means it's impossible that the event will occur. That's what it means. It's impossible for that to happen. Probability of 0.25 means it's unlikely that it happens. So when I say what's the probability of rolling a 3, which is 0.17, that falls in between here. So that means this is unlikely that it would happen, that I would just randomly roll a die and roll a 3. It's unlikely. Okay? 0.5 will mean that the event will occur half the times. Okay? So, for example, rolling a number greater than 3, that will occur half the times because we found that it was a probability of 0.5. Rolling a number less than or equal to 4.67, that's getting very close to a 1, where 1 means that it is certain that the event will happen. So having a 0.67, it's about over here somewhere. It is highly likely that the event will occur, rolling a number less than or equal to 4. And rolling a 3 or a 4 is a probability of 0.33. It's a little bit over here in between 0.25 and 0.5. So it's unlikely that I will roll a 3 or a 4. So you have an idea what these numbers means. The greater the number or the closer the probability is to being 1, the more likely it is to occur. So if you get a 0.75, a 0.8, a 0.9, that means it's very likely that the event will occur. Okay? Now, another thing I want to mention is that this probability that we are calculating is called a theoretical probability. And what that means is that in theory, these are the values of this occurring. We saw that in theory, what is the probability of rolling a 3 or a 4 is 1/3 or 0.33. That's in theory. Experimental probability would actually test rolling a 3 or a 4. Let's say I ask you to roll a die 50 times, okay? And to record your results for each time you roll. And let's say you make a table to record this experiment, okay? Here's the roll number. That means first roll, the second roll, the third time you roll, the fourth and the fifth and the sixth, etc., all the way to 50 rolls, okay? And you're going to record your outcome. The outcome, what did you roll when you actually threw that die the first time? Let's say you got a 6. Let's say the second time you threw the die, you got a 5. And the third time you got a 4. And the fourth time you rolled the die, you had a 2. And the fifth time you got a 3. And the sixth time you got a 4 again. And the seventh time you got a 1, and etc. And you keep going till you've rolled that die 50 times. And you record each one of the numbers that came up, okay? Now, this is a real experiment. We're actually conducting this experiment. This is why it's called now experimental probability. What do we get if we experiment on something, okay? So to calculate the experimental probability, we need to do the number of successes, which is very similar to favorable outcomes. That means if I'm trying to find the probability of rolling a 3 or a 4, how many successes did I have or how many favorable outcomes? I would come here to my table and I would count all the times I got a 3 or a 4. So here's one success. Here's another success, and here's another one. Here's another one. So far, I have 4. And let's say when I'm done with my list doing 50 rolls, let's say I had a total of 16 successes, okay? That means favorable outcomes. I would write 16 here. And then the number of trials, that means how many times did I actually conduct the experiment? Well, I did it 50 times. I threw that die 50 times, okay? And this is how we calculate experimental probability. And then 16 over 50 would be 8 over 25. You can reduce that to 8 over 25. And with your calculator, you can find that 8 over 25 is 0.32. Now, is this close to our probability that we found in theory? Very close, okay? So sometimes it will be very close, sometimes not. But in theory, the greater amount of times you conduct the experiment, the closer you will be to the probability that we found in theory. So let's say you conducted the experiment 50 times, the trials, you did 50 trials, and this was not close at all. It was way off. The more times you keep rolling that die and finding your successes, the closer it will get to 0.33, okay? So here I hope you understood the difference between theoretical probability and experimental probability. Theoretical is what we do in theory. Experimental is when you actually go through the experiment and record data and then look at the number of successes versus the number of trials. I hope this is easily understood. In the next part of this topic, we will discuss how to use probability to make predictions. I'll see you then.